Your data isn't broken, your requests are. Your dashboards look green and everything seems fine, but your data still isn't usable, and that's the problem most teams don't see. Because the hidden cost of failed requests isn't technical, it's strategic. You're on the Proxy-Seller channel. I'm Mark, and today we're breaking down why your data isn't as valid as you think, and how failed requests quietly drain value from your data stack. To understand why this problem keeps repeating, we need to step back and look at the system, not individual tools. Google Cloud describes this phenomenon as the data value gap. According to their research, only about 10% of the data generated each year is actually original. The remaining 90% is replicated, copied, reprocessed, transferred, and stored again across different systems. This doesn't mean that 90% of the data is bad. It means that data production has scaled much faster than data usefulness. Enterprises are extremely good at generating data. They're good at moving it, duplicating it, and storing it. But they struggle with something much harder, turning raw data into consistent, usable business input. As data volumes grow, validation, filtering, and contextual checks don't scale at the same pace, so the system creates the illusion of progress. More pipelines, more dashboards, more traffic, but not necessarily more value. That's the core of the data value gap. We measure activity, throughput, and volume, while value quietly erodes upstream, long before analytics or AI ever come into play. And this is where the parallel becomes impossible to ignore. The exact same illusion exists at the request level. We count how many requests we send, how much bandwidth we consume, and how large our IP pools are. But we rarely ask the harder question: how many of those requests actually deliver usable data? We measure volume, but we lose value upstream. Before we talk about failed requests, we need to clarify something fundamental. What does invalid data actually mean? Because in most systems, data is treated as valid the moment a request returns a success code. But data quality has nothing to do with volume or delivery alone. It's defined by a set of concrete properties: accuracy, completeness, timeliness, and validity. Let's translate that into practical terms. Accuracy means the data reflects reality. If prices are outdated, locations are wrong, or fields are misaligned, the data may exist, but it's inaccurate. Completeness means nothing critical is missing. A response can arrive successfully, but if half the required fields are empty or stripped out, it can't be used. Timeliness means the data arrives when it still matters. Data that comes too late is often just as useless as data that never arrived. And finally, validity. Research on data quality, including the Dimensions of Data Quality framework, defines validity as whether data conforms to expected formats, rules, and usage constraints, including whether it can be used legally and contextually for its intended purpose. This is where many teams get misled. A request can succeed technically, return HTTP 200, pass through the pipeline, land in storage, and still fail analytically. That's because success codes measure delivery, not usability. Academic research in Frontiers in Big Data highlights this exact problem. Most data quality issues are detected after ingestion, not at the point of collection. By the time teams realize data is inaccurate, incomplete, or late, the cost has already been incurred. This creates a dangerous assumption inside data teams. If the system didn't error, the data must be usable. But in reality, success codes don't measure usability. They only confirm that something was delivered, not that it was usable, trustworthy, or fit for decision-making. Most teams don't miss failed requests because they ignore data quality. They miss them because their systems are not designed to see problems at the moment they occur. Research published in Frontiers in Big Data shows that data quality issues are primarily detected after ingestion, not during data collection. By the time data reaches storage, analytics tools, or machine learning pipelines, teams are no longer observing individual requests. They are working with aggregated datasets and metrics. This timing is critical because many failed requests don't register as failures at all. They return responses, pass through pipelines, and never trigger alerts, even when the data is inaccurate, incomplete, delayed, or unusable. That's why data quality issues are often described as silent. They don't stop systems from running, but they degrade outcomes over time. What research consistently shows? Data quality problems are detected post-ingestion, not at the point of collection. Many issues only become visible in context when data is actually used, and errors accumulate without causing operational failures. At the architectural level, data observability explains why this blind spot exists. Observability is not the same as monitoring. Monitoring shows whether systems are up, Observability explains why data behaves the way it does. In most enterprise data stacks, observability begins after ingestion. Everything before that, external sources, network behavior, request-level responses, exists outside the observable boundary. These blind spots are known as coverage gaps, and they are a structural property of modern data architectures. If you only observe data after ingestion, you'll never see request-level failures. This is why dashboards stay green while data quality quietly deteriorates. The system is functioning as designed, it just isn't designed to measure validity. When teams talk about failed requests, they usually think in technical terms, but the real impact isn't technical, it's economic. Every failed or unusable request creates direct costs that are easy to overlook. You still pay for traffic, you still pay for retries, and you still pay for compute, storage, and orchestration, even when the data itself has no value. Direct costs, traffic costs, bandwidth is consumed regardless of usability. Retries, failed or partial responses multiply request volume and spend. Infrastructure overhead, pipelines process unusable data the same way they process valid data. These costs show up on cloud bills, but rarely get traced back to request-level failures. More dangerous are indirect costs, because they don't appear in budgets, they appear in outcomes. Invalid data quietly distorts analytics and models. Machine learning systems train on incomplete or biased inputs. Dashboards reflect partial reality. Decisions are made with false confidence. Industry analysts like IBM and Gartner consistently report that poor data quality costs organizations millions of dollars every year, not because systems fail, but because they keep running on bad inputs. You don't pay for failed requests once, you pay for them across your entire stack, at the network layer, at the infrastructure layer, and again in analytics, models, and decisions. The longer these failures remain invisible, the more expensive they become. At this point, the conclusion is simple. As companies move from experimentation to real business impact, infrastructure performance becomes the deciding factor. It's no longer about how much data you move, it's about whether your systems can reliably deliver data that can actually be used. And this is where most teams hit the real bottleneck. Not in models, not in analytics, but in data validity. Validity isn't a nice-to-have metric, it's the bottleneck. If the data entering your pipelines isn't accurate, complete, timely, and trustworthy, no downstream optimization can fix it. The biggest risk today isn't system failure, it's confident decisions built on unreliable inputs. If your data isn't as valuable as you think, your decisions probably aren't either. That's why valid responses are becoming the new enterprise currency. They define how reliable your data is, how mature your infrastructure has become, and how far your business can scale without losing control. At Proxy-Seller, this is the language we build infrastructure around: trust, observability, and responsibility. Because the future of data isn't about having more traffic, it's about having more validity. We help companies working with big data, AI models, and automation build production-ready proxy layers, secure, ethical, and scalable data collection infrastructure. Subscribe to the Proxy-Seller channel for real-world cases, market insights, and practical guidance on building data infrastructure that actually delivers value. I'll see you in the next video.